0.10, exercise 5.1.
It is possible for acrobatic to rebound to a height greater than her initial height. If so, how? If the acrobatic bends her leg and crouches immediately after oh, this is
No, not
answer.
this one, this one.
Oh,
This one,
an 8 kg
5.10.
block drops straight down from a height of 1 meter, striking a platform spring having force constant 1 times 10 to the power 3 Newton per meter. Find the maximum compression of the spring.
Okay, so now we have a block. This block is 8 kilogram, and you drop it 1 meter. After 1 meter, it possesses a certain amount of kinetic energy. And when it touches this platform here, the kinetic energy will be converted into the spring potential energy. Not only this kinetic energy, but also it will drop a further distance of d. Okay, so this during this stage, the spring is compressed. So the potential energy is from 1 meter plus another d. That will be the total potential energy. So this potential energy is converted into the energy stored inside the spring. So it will be something like this, right? Something like this, the second stage. Finally, it will be something like this. So the block has compressed the spring and come to a rest. Okay. After that, it will spring up again, but that is a different case already. Okay. So we are going to use the conservation of energy. The initial part is this one. Okay. So we calculate what is the total initial energy and what is the final energy. So these two, they must be the same under the conservation of energy. Okay. So what are the energy involved in the first case here? Of course, the usual one will be kinetic energy, potential energy in the spring, potential energy, gravitational potential energy. So, okay, so this is the initial part. Right? So at first, the block is not projected down. It is dropped down. That means the initial velocity is zero. So this one, the initial velocity is zero. This one. Okay, the kinetic energy initially is zero. Then the spring potential energy, this is the spring. The spring at first is not compressed because the load is still above the spring. So the initial potential energy in the spring is zero. Okay, then we have the potential energy. At this height, it has a potential energy of both the 1 meter and also the compressed 1 meter. So the total potential energy is mgy. Okay, it depends on the y here, depends on where is the 0 point, right? So the 0 point is here, the zero level is here. Okay, next we look at the final potential and the final energy. So the final kinetic energy is also zero because after dropping on the platform, it will finally come to a rest. Okay, so the final potential energy of kinetic energy is zero, right? The final gravitational potential energy is also zero because we define this as a zero level. Okay, right. Okay, let us look at the question. Find the maximum compression of the spring. So if you want to find the maximum compression of the spring, that means when the spring is at its lowest level here, it will come to a stop. Right? Oh, what is this? Okay, right. Then when it comes to a stop, it has a certain amount of spring potential energy stored in it. So this will be the spring potential energy. Okay. Now, how this spring potential energy comes about? I don't know whether you can still remember. Is the formula is half kx squared. This one, half kx squared, right? So the formula is half kx squared. The initial potential energy is mgy. The final potential energy in the spring is half kx squared, right? Now, m is the mass of the object, g is the gravitational pull, and y is the height. So the height includes the 1 meter and also the compression d. Then the spring potential energy is half kx squared. Half is of course half. K is the spring constant, is given, the spring constant is given, and x is the compression. So the compression is d here. Compression is d. So okay. So the m you replace with 8 kilogram, g is 9.8. The height here is 1 plus d. So the height is 1 plus d. Where is it? The height is 1 plus d. The y 1 plus d. Then the spring potential energy half k x squared. The value of k is this one, 1 times 10 to the power 3. Okay, the spring constant. So it's 1000, and the compression of the spring is d. So if you say kx squared, so here will be d squared. K is 1000, d squared. Now, when you expand this expand this equation, 500, the 1000 and the half will cancel away. So we have 500 d squared. 9.8 times 8 times d. So it's 78.4. The other one also the same, 78.4. So using the formula for quadratic equation, minus b plus or minus b square minus 4ac and so over 2a. So we get the final compression of the spring is 0.482 meters. So you must know how to solve the quadratic equation using the formula. Any question on this conservation